We now have our last presentation before lunch. So we're in the world of enterprise search now. We're going to hear from Franck from Box. And Jay has been an astronomer. You've been working in astronomy. Exciting. He's worked for PlayStation. And now he's at Box and improving search relevance for customers across industries and countries. A laudable ambition, I'm sure.
Impossible, but
so he's going to be talking about enterprise search relevance at Box.
All right. Well, thank you, number one, for showing up before lunch. I know it's a tough slot to fill, but thank you. So yeah, I'm a ML engineer at Box. I've been there for about 2.5-ish years, and the basic idea that I'm trying to convey here in this talk is on simplicity and why you may want to adopt some of these principles. So for those of you unfamiliar with Box, Box is the leading content cloud. So what does that mean? Basically, you put your data in Box, it's safe, it's secure, you can bring in any apps that you want, you can open up a PowerPoint, you can build your own apps on top of Box, and you can let your organization use the data to the best of their ability. So, pretty cool. If you open up Box Search, whether on Drive or your mobile, or just go to box.com, you're going to see something like this. You start typing in your query. You are going to get results in a quick search pull down. If you hit enter, you're going to get a full search across the index, and hopefully these items will be relevant to you. So we've heard from a number of talks today across industries, across use cases. I want to highlight some key distinctions that Box has to deal with that maybe some of the other use cases we've heard about don't have to deal with. So number one, Box is at a certain scale and security sort of standpoint that is incredibly important. We host some of the world's most sensitive data, S&P 500 companies, governmental organizations, you name it, we have to keep it secure. We have to keep it secure across numbers of different governmental and country legislations. There's a number of other sort of security standpoints that we have to deal with, but that is one of the key tenets of Box.com. We also deal with a ton of data. I'll show you a couple numbers in a little bit. But having scalable solutions is incredibly important. We also have to be available 24/7, all the time. If you are looking up a case file for a legal case at 4 a.m., you need your results, and we want to be there for that. So everything that we're building, everything that I do, has to conform to these first, and everything else is almost secondary. So I'm going to put some numbers on the slides here. So we have approximately, things change of course, but we have about 200 terabytes. That's our index size. That is about 200 billion documents. We receive about 10,000 updates per second to our index. People are constantly changing, like they're adding new documents, they're updating documents, they're collaborating with others. We have to be able to respond to those. On the smaller side of things, we're at about 100 queries per second. We're actually returning. So that makes it easier on my end, relevant side. But yeah, the size of our index is pretty impressive. Okay, so how do customers actually use Box? This is also quite a bit different from some of the other talks that we've had. We are mainly focused on keyword search. There's almost no natural language sort of queries that go through our system. There are some, I would say. People do use 1 or 2 tokens and throw those out there. Most customers are using Box to find content they know, or they know something about. It may be an order ID, it may be a name, an industry, but they're not typically using it for discovery, which changes the scope a little bit. There's almost no question answering. I think maybe you'll see a few questions that someone copies and pastes incorrectly or something, but very, very few people actually use that. So based on these tenets, we've built a certain philosophy in our group. And these are the three main things that I want to emphasize here. So going through the rest of this talk, please keep these things in mind. Number one, make it universally available. So the Relevance team is actually a fairly small group. It's not that many people. We have to focus our efforts on things that deliver high ROI. And by keeping things universal, you can deliver more consistent results with greater velocity. So what does universal mean in this context? For me, it means that when I deploy a model, when I do some analysis, when I do any change at all, I want it to be able to affect as many people, many customers as possible. So generally, we build one model for global search. That's it. You can think of the complexities of building maybe one model for a single enterprise or a single industry or a single language, but then you expand it to 40 countries, 10 different languages. It just becomes untenable for a small team. Also, long-term maintenance, tech debt, these are things that you can incur very rapidly if you start deploying complicated scenarios, multiple models. And always, you got to keep the safety and security of your users' data in mind. Okay, so architecture. A user comes onto box.com. They submit a query. This triggers two separate things happening at the same time. Number one, we send the user ID to our Redis cluster. This retrieves our top K most recently accessed documents. We also send this to our backend search service that's written in Scala. What this does is it formulates a query for ingestion by Solr. We send that out to Solr, get some results back. The search backend service here, that's the green box that I'm highlighting, that is going to do a number of things here. Once it has the results from Solr, it's going to do things like permissions checking. We want to make sure that the users that are getting documents back from Solr are getting the correct stuff that they are allowed to see, either that's in their enterprise or that their admin or permissions allows them to see as well. So there's a lot of kind of permissions checking, security checks that happen there. Once you have some of that business logic filtering done, you send the top K documents to our AWS reranker. So AWS SageMaker is a one-stop shop for exploring your data, building models, deploying endpoints, etc. So this is just a simple TensorFlow model that we'll talk about later. And then we send out those reordered documents to the end user. So what does the Relevance team actually do? What are our best performing, job functions, let's say? So we do a lot more than this, but these seem to be the knobs that we can tune and actually drive results the best. So we do Solr query field boosting. We use some timestamp-based features in Solr to also boost results for more viral documents. We obviously build the reranking model. And then we also handle our A/B testing and experimentation platform for use by ourselves and other teams. So let's start with a simple thing, or simple doesn't mean easy, but definitely a little more simple, is we use the Solr query field boosting scores to great effect. And so if you're familiar with this, I apologize for simplifying this too much. If you're not, I think this could be helpful if you're starting out your journey in search relevance. We use the edismax parser. And what this means is that you are going to be looking for each query across a number of indexed fields. And then each of those fields is going to have a score. We want to make sure that that score is actually tied to some relevance metrics. So let's say we are making the query of just simply box. And you have two documents. They have different fields, title, and description. It looks like from this very simplified example that your document 2 is a little bit better than document 1. And so we would want in some way to boost that document up, the search results. Number one, it's got 2 hits in both title and description. Excuse me. And also, it just seems like it's a better fit. So what do you do? Well, I guess the naive approach is that you could just start manually tuning the field scores for these. You could give description scores a little bit of a higher boost, and you could see how that plays out in an A/B test. And I'm sure that could work. What we typically do is we use a genetic algorithm. And what this does is it's going to help us learn to rank with our query fields. So let's say you're starting out your journey and you wanted to try something like this. What kind of data would you need? So what you want first is you want a bunch of logged files that you are getting returned from Solr. So you want the Solr scores for a number of your fields, title, description, what have you, metadata if you have that. You would get the document IDs associated with that query, and then hopefully you would get some sort of ranking. So in this case, we have an actual ranking that's determined by user interactions. You can, do your own thing there. But let's say that for the first document in this list, a user at Box has interacted with the document by sharing it with a friend, or editing it, or adding a comment to it. The second document had no interactions at all. So we're just going to say, probably not a good result. So we have this data. This is our basic algorithm for building this in Spark. I will say, I do not think you should do this yourself. There's a number of packages nowadays that you can build genetic algorithms very easily. This is going to be a very high-level overview of how you might do that. So first off, we're going to grab all of the labeled queries that you have. Let's say you grab 3 months of data. For us, that's quite a few queries. You're going to get the labels. You are going to get the title scores or whatever field scores you have. Let's say that you have already 3 or 4 experiments already running in production. And each of these has slightly different weights of query fields. First, you are going to want to deboost the scores back to their naive Solr level so that everything is on the same page. Then you are going to do a min-max scaler just to get everything from, let's say, 0 to 1 for each of your fields that you have. So in the example here, I have a title score, a description score, and the labels. And then I just run a min-max scaler on this data. This is per query, I should say. So for those of you not super familiar with Solr scores, they're more about ranking than like having an actual value. So relative to other queries, it doesn't have that much inherent meaning. So you want to basically make everything on the same level across different queries. Now, this is a little bit of the special sauce that we throw in. We are going to use, in our case, PySpark. We're going to build a very simple point-wise linear model to get some initial coefficients. So we just grab linear regression, you train it on the data of your normalized features, you fit it to whatever label that you have. So like our ranking system is from 4 to 0. This gives you some coefficients. It gives you titles and description field in this case. And this is where we are going to start with our naive version of the weights. So whenever I think about genetic algorithms, I always think of them as little amoebas or some simple, organism. And this organism basically does one thing and one thing only. And we are going to try to optimize those amoebas to do the best that they can do. So we initially started with some basic weights from our linear regression. we are going to build a bunch of amoebas. So I've got 3 here, and they're all slightly different. You know, we've introduced a little bit of perturbation to the system. Each of these coefficients is equivalent to the genetic code of the amoeba. So we're testing out which has the best DNA, basically. And then if you are feeling really fancy, you could throw in some mutations to really explore the parameter space. Like we have a mutation down here, which is way off in left field. And then we take each of these amoebas. Oh, this is a Dolly inspiration of what amoebas ranking. You know, they're chomping on numbers and getting hopefully good results. So you take your amoebas, you apply them to the data, you re-rank the results, and you see which has the better metric. So here, let's say we're just using NDCG. You are going to make sure, or you're going to test which amoebas are best at re-ranking by NDCG. You are going to take the variants that perform the best in this case, and you are going to push them into the next generation. So you can do this in a number of ways. There's tons of strategies that you can use. You can just grab the top K. You can do some sort of weighted mean to push these into the next generation. But this is the basic idea. You start grabbing many, many generations of amoebas. You record the best, and you keep pushing until either you hit some iteration limit, or let's say that it has converged to a solution and you're happy with it. So for us at Box, the current system that we have in place has not changed in about, well, since I've been there. So 2.5 years, our genetic algorithm really keeps converging to just about the same solution. So we're pretty confident in this. I will say that you can also use this with phrase fields in Solr as well. You don't just have to limit yourself to query fields. But this does seem to be like a pretty decent solution. All right, so now you have your documents re-ranked at least by BM25, and you hopefully have some good coefficients boosting those documents. At this point, you probably want to improve your results further. And so there's 2 main ways of doing this. You can add popularity signals, which folks have talked about in the last couple of days, or you can add some recent information, some virality signal that will help your system out. And so let's go with the virality part first. And so we use a familiar approach to many of you. It's boost. So this applies a multiplicative boost to whatever Solr score your document has returned for you. And so we use the familiar reciprocal function. And so for those of you unfamiliar, on the left-hand side of the screen, we have what a reciprocal boost might look like. The x-axis is the time, or the days in this case, between when the query was submitted and some timestamp field that you care about, when it was updated, created, what have you. So the most recent documents, of course, are going to be boosted the most. They're going to decay fairly quickly, and then more slowly over time. The reciprocal function has a few main parameters. You have the value of x, which is like your timestamp difference. You have a value of m. You can think of this as like an inverse timescale that you care about. And then you have a and b, which shift things around a little bit. So I want to call out a few great blog posts and things that we saw that helped inform us of this cool feature. And those are at the bottom. So we actually, someone in my group long ago introduced a further parameter. I'm not exactly sure of the history of that, but the basic idea is that you take the value of x, that timestamp delta that we discussed earlier, and you raise it to some power. So for whatever reason, that was you just take the square root, so 0.5, and then you run the full system. I don't think you have to do that necessarily. I think you can get very similar shapes to the reciprocal function just within the native parameters, but just for full disclosure, that is what we're doing. Our value of m is subsequently decreased pretty much by quite a small factor, and then our a and b values are approximately 1. So pretty simple. So how do you get these parameters? You have the function. You maybe have some idea, some domain expertise of what the value of m might be, your time scale that you're interested in. What we did is very, very simple. We grabbed the data that we have for actually interacted with documents that came from search. We looked at their updated field. We normalized it, quite simple, and then we fit the reciprocal function. So nothing too crazy there. If you look at the actual data, there is some kind of cool, interesting features there. You can see that, of course, it decays very quickly. So right after about 1 day, the value of a document to a user is fairly small. So virality is important for us, for our customers, I should say. But there's also some kind of cool features in there, like at about every, let's say, 6, 7 days, 14 days, 21 days, 28 days, people are still coming back to those documents. So there is some kind of cyclical nature in there. No one has ever tackled that as far as I'm aware in my group. So that would be something cool to try out later. But yeah, just a cool little artifact. So you have the data. You have your fit for the reciprocal function. The next thing you're going to want to do is A/B test it. So this function that I'm showing you right now, while that looks like a pretty decent fit to the data, that wasn't the best fit that we saw. We had to do some exploration of an A/B space in order to get the best result. And we're still learning. This is not a finished solution. All right. So you have your BM25 matches. You've boosted them in a number of different ways. Let's make some more improvements. And at this point, we are going to start using popularity signals. So what we do here is we are going to use a Tensorflow ranking model. For those of you unfamiliar, it's a pretty well-maintained system. It seems to be very scalable for us. We haven't had any problems with it. It's got some cool out-of-the-box algorithms and packages that you can adopt. We grab the top 25 documents and send them to the reranker. Your own results are definitely going to vary, but that can be determined by product folks or limitations on your system. When I asked DALL-E to kind of build me an image to represent re-ranking documents by robots, I got something like this. Tons of things in the air. You have no idea why you're getting these results, but hey, seems to work. So what do we actually send in to our re-ranking model? So obviously we have our Solr ranking, or your Solr score, as a main feature. But then you also can include your timestamps. When was this document created? When was it updated? When was the last time someone accessed this document? You can have user interaction scores. So as I mentioned earlier, we had a Redis cluster hosting the top, I think we have 500 documents that this user has accessed and their timestamps. You can look at when those documents were last interacted with by this user, if they ever were, the parent folders all the way up the tree of their document system, when were those last accessed by the user. You can grab individual Solr field scores. So we mentioned, like, you could grab the title field score from Solr, the document field, the metadata field. You can include all of these features into your network. And then finally, the popularity signals. How many times has a number of distinct users edited this document? Those are all very, very helpful. So you grab your data. So this looks hopefully sort of familiar. You grab your data per request, and you're going to do a bunch of scaling on it. So we found that including the raw score, here I have title score from Solr. We have a request scaled score. So per request, what is the min-max across those documents returned? And you have a Gaussian score. So I mentioned earlier that the difference between different queries, Solr scores, they're sort of relative. They're not super important. We have found that globally scaling the values in A/B tests seems to be a good feature when added to the re-ranker. I don't know why necessarily. If you do, come up and talk to me. but without one of these features, the score is noticeably worse. So adding all of these, for whatever reason, seems to be the best. So we've got raw features. We have the globally scaled features. We have the query scaled features. And then finally, we have binary features. Are you the owner of this document? Are you the editor? Is this a file or a folder, etc.? We added all those out, and we just basically let the neural network decide which features and interactions are important and which are not. As a group, we've talked a few times about using SHAP or something similar to do feature attribution. What's important in interpretability for the network. We've never done that. Then we saw this recent paper about weighted SHAP. So if you're interested in those sort of papers, this seems to be really interesting. Better way to attribute features and importances, but we haven't done that yet. So we just let the system decide. A few callouts. So missing features, for many data scientists, your first data science project, you're just filling NAs with 0 or the mean value. For something like this, especially when you're dealing with timestamps or these reciprocal functions, this is something that can really change your results. So having some domain expertise, having some careful thinking parties about what you should do, how you should fill in these values, very important. I'd caution you against just filling in naively. And categorical and binary features, if you're including those, keeping those things in mind is also important. The actual model itself is super simple. We don't have like a super deep model. 2 layers, a couple hundred nodes, that's all it seems to care about. We get perfectly good results with that. Softmax loss, nothing too fancy. Within about 100,000 queries, which for us is not that much, just a few days of data, we have already achieved basic convergence for the model. So we don't need many millions of rows or 3 months of data. It seems to converge pretty quickly. And then lots of dropout. So as I mentioned earlier, all of our models are global models. It doesn't matter what the user is querying, what language, what region. It seems that having one single model to rule them all is perfectly acceptable and seems to work really well for us and is super easy to maintain. So whenever I go to talks like this, I'm always really interested to see not what worked, but also what you tried and failed to do. And so I have a nice list here of some of the things that we've tried and failed. Adding context features, that always seemed like a no-brainer to me. Like, oh yeah, context should matter to the user. Had no effect at all. So what time zone you're in, what day of the week you're querying, nothing. Had no change. We've added some document interaction networks, no change at all. We've sent more and more items to the reranker to be re-ranked, no change. That could be latency issues, to be honest, but didn't seem to help or hurt at all. We've added a bunch of categorical and embedding features. What type of file is it a PowerPoint? Is it a box note? No change at all either. One of my favorite ones, or one of my most hopeful ideas, was using a loss function that mirrored our metric, so approximate NDCG. I was really hoping after reading this paper that this would be the game changer for us. No effect at all, and maybe even a little worse. So Softmax it is. So a couple of things just to point out, because I think it's fun to wallow in other misfortunes of other people. So I'll let you do that for me. Having logging, especially at the feature extraction layer of your system, is incredibly important. You need to know where your features are coming from, what they are, what's the value, what is missing from your system. Having a good system that never fails is important, as I mentioned earlier, but also just having a bunch of missing features that you're not, accounting for is just as bad. At one point, we thought that adding just tons of context information would be helpful to the user, so we started sending large JSON blobs to be processed by the reranker. That was a bad idea. So don't do that. When we learned that that actually was a bad idea, we started working with other teams saying, hey, could you process this data in Scala, let's say, do it that it's in a thread safe way, communicating with those teams about what you actually expect the features to be in. You're using natural logs, they're using base 10. These are simple things that you would not think would happen, but have happened, and very important to your end results. So you have all these systems in place. Who is the judge that is going to be determining which of your experiments are good and which need to be revised? So you need an owl, a numbers owl. Thank you, Dolly. So for us, we use a very simple JSON system. If you're unfamiliar with JSON, it's like a JSON building scripting library. You can have variables. It's fairly easy to use. Each experiment in the scope of simplicity has a certain amount of traffic. You can pin specific users or enterprises to that model or that experiment. This can help with debugging, especially if you want to roll out to yourself as a user or your enterprise as a user. And then you have all of your configurations in one single place. So which endpoint are you hitting for your reranker? What are your Solr configurations that you're using? This is all in a single JSON blob. It's very easy to configure. You don't need an expert to roll these out to production. So it's very simple. Per experiment, per week, we get a weekly roundup. We look at let's say the CTR if you care about that, or the NDCG. Did your NDCG go up, but your latency went up by a factor of 2? Maybe that's a problem. So we just use this as kind of our benchmarking system. We do bootstrapping to get our stat sigs. That gives us a mean value, some confidence intervals, as well as just your normal A/B sort of t-test system as a sanity check. And we just see what is going on. What are the best models performing? What can we tune or debug? And what should we retire? All right, so as a recap, at Box, we are very committed to safety, security. You're probably maybe even tired of me saying that at this point. But by building simple global models, you can really achieve high velocity in your teams. You don't have to tune every single little thing, deploy to this customer and not this one, have an exclusion list over here. You can make it fast. You can make it easy. Your team isn't going to be frantically trying to debug everything. Everyone can do everything. I'm a huge believer in that. We use Solr to do our boosting for our candidate sets. So boosting recent documents, doing the query field boosting, that seems to be a pretty easy solution for us and pretty scalable. And finally, we use our reranker to boost the popular items, as well as just combine all features and get some of that nice non-linearity in there. And that seems to also work well. So thank you for your attention, and I'm open for questions.
Thank you, Jay. So let's move swiftly on to some questions. Do we have a question from the room? Yes, just here. Thank you.
Good talk. Really good stuff. My question is around your reranker. SageMaker rocks. It's really, really good. My question is the choice of using a shallow neural network versus gradient boosted trees like Lambda Mart. I was wondering if anything else was measured. You said your parameters were like 100-ish?
100, yeah.
So I was wondering with that parameter scale, what made y'all make that decision, and if you did any other experiments?
Part of that is definitely legacy. So it seems to work for us in terms of just we have all the pipelines in place, all the code's written for it. I've never used Lambda Mart, so I heard a talk just yesterday. Oh yeah, maybe I should try that someday. I don't know, it seems to work. For our results, we get very good NDCG for those folks that actually click on items. So it seems like any lagging problems in our pipeline is in the candidate set generation, especially with a huge enterprise style search. That's difficult, but I'm happy to try it. Let's talk afterwards if you think that Lambda is the best part. But
Great. Okay, so let's go to an online question. Bogdan asks, why did you choose Solr or Elasticsearch?
once again, I think that's more of an infrastructure side thing and a legacy thing. I was not there when Solr was chosen. It seems to work. I mean, I think that the index size that we're working with, I don't know. It's just the way that it goes.
Okay, so a quick connected question. He asks, how do you host your Solr solution?
Right now, we are migrating to GCP to host all of our Solr.
Great, thank you. Okay, do we have another question from the floor? There we go. Okay. I'll come to you in a minute.
Hi, are you using any kind of a feature store to sit between your source data and SageMaker?
Apart from the Redis cluster, which hosts that recent JSON that I was mentioning earlier, our feature store is Solr, essentially. Yeah, so we're just using that as our feature extraction layer. It has some additional non-indexed fields in there that we kind of use as a feature store. Maybe it's a hacky solution, but it seems to work for us. Yeah.
Fantastic. So another question online. Dave DeBar asks, have you compared the genetic algorithm approach to alternative methods, e.g. Bayesian optimization with a Gaussian process regressor?
I have not used that. Can it run in Spark? Or, I mean, can it run at Box's scale of number of documents?
Dave, do you know? Dave online? Because I certainly don't.
I've tried PyMC3 to do some basic stuff on box scale data. It's just so incredibly slow. Yeah.
Okay, so scale's an issue when choosing a method. Okay, so James.
That was basically my question, but in addition to PyMC3, there's Optuna, and that has Bayesian optimization as well as the CDOF algorithm, and it converges really quickly. So,
Let's talk later. That sounds cool.
Let's talk later.
Awesome when as a presenter you get a hint to do something better with your own system from
like
your
it.
audience. And that's
Yeah.
great. Okay, so we got another question from Jeff. Hi, Jeff. Jeff at CB Insights. Could you explain some more details on how your A/B test system works with your API and search engine to choose a ranker?
Yeah. So basically, as I mentioned earlier, you just have our experimentation system. It tags a specific user or enterprise to that experiment. It has a reranker and whatever Solr parameters you want. Hopefully you keep those stable. Then you are just looking at which one is performing better in terms of mean, standard deviation. I mean, you could just look at Welch's t-test or do the resampling system that we have here. And if you are consistently beating the baseline, champion versus challenger, you adopt the new one as your champion. I don't know if that was, let me know if that wasn't sufficient. But.
Jeff, I hope that answers your question. Tiho.
Great talk. It looks like you've built a very effective system for optimizing NDCG. I'm wondering whether you're also looking at other ways of evaluating the quality of the search beyond NDCG, and examples might be session-based metrics, user satisfaction, searches per user, other factors. Because it seems like in the system that you have, you've optimized a metric pretty well, and probably at this point, I'm reading there's diminishing returns on that measure, but I'm wondering whether there are other measures that would be better indicators or better opportunities for optimization.
So first, you mentioned I built the system. I want to very strongly emphasize that this is a work of many people, many talented engineers. I'm just the messenger here, but thank you for that. So I would say that is mostly correct. We have hit some sort of entropy maybe in our current solution for optimizing NDCG. We do sessionize our results. I would say most users have single query sessions. So as I mentioned at the start, most of our queries are very simple, 1 or 2 tokens. They're not usually expanding their query that often. We've tested things like that. We have some sort of user interaction metrics, but that can be such a lagging indicator. You know, maybe that enterprise or that user has stopped querying because they left the company. So those sorts of things are more difficult and probably very important, you know, to the health of the ecosystem. But that is not something that we optimize directly for.
Great. Okay, so one more question from William online. What's your rerank window? Do you have the problem of latency added for the rerank step, with, you know, data transfer or extra calls?
So the SLA, I believe, is 500 milliseconds. So we generally don't have an issue with that. I think some of our Solr calls are of order that with our giant index. So that is not typically an issue. Obviously it happens, but that's not our biggest concern.
Thank you. Any more questions? I think we had one here. Yes.
Hi, I was just wondering, for your ongoing experiments, can you go into more detail about how you determine relevance for the NDCG calculation?
Sure. So this is a implicit signal. We are using user interactions per document inside a time window. So let's say you get 10 results. Within those, let's say 10 results, within 10 minutes, are you clicking on items? Are you sharing them with friends? Are you editing that document? Is this what you actually wanted? And so it is sort of a little bit of a magician's touch sort of thing. Is a preview worth more than a comment or an edit? I don't know. It seems to work for the most part. We have kind of hit some level of trust in the system, but in the end, it depends on the user. Some users probably have different expectations about what is relevant and what is not. But that's a tough question. If you have any ideas, come talk to me later. I'd be happy to chat.
Okay.
Hi, it's a great talk. So I just want to know your learning part, like context, adding the context aware. So are you trying to add the context of the document or context of the users? So which one made failure, or you break it?
That's a good question. It's the context of the query. So in the TensorFlow ranking system, you have the notion of a document feature. So per document, the title score is 3.5. At the head of the list of the TensorFlow ranking system, there is a notion of, for this query, what is the context of that query? So that's where you can include the actual query terms. You could include the timestamp of the query, the language of the user that's making the query. And so that's the layer that we're adding it to.
Okay, I think we've got maybe time for one more question. Doug? Sorry, could you use the mic so we can hear it on the Zoom?
How many generations typically does your genetic testing take to converge?
In my memory, which is occasionally faulty, I would say of order less than 100. But, you know, I will say this. We are starting from a baseline. So this is, you know, some sort of like backslapping thing. We already know the essential order of the rankings. We already have a basic linear model that we're starting off with. So maybe if you were starting with a naive list of unity sort of weightings for your query fields, maybe it would take longer. I hope that's a decent enough answer.
Fantastic. So please, J. Franck.